So let's see the next question. This one is like this: if given that if sin x is equal to cos square x, then you got to show that cos square x into 1 plus cos square x is equal to 1. So this is a problem. This is a very easy problem, but somewhat tricky actually, I couldn't say. So sin x is equal to cos square x. That is, they have given us. So if I can square it on either side, I can say that sin square x is equal to cos power 4x. So I can, if I see the cos power 4x, I can replace this with sin square x. So this is the crux you can see. Okay, now let's go back to the problem. That problem is given as the LHS part is cos square x multiplied by 1 plus cos square x. Okay. And now let's multiply the cos square x inside with the bracket, cos square x inside. So cos square x into 1 is cos square x, and cos square x multiplies with cos square x and it becomes cos power 4x. So just now we have sin square x is equal to cos power 4x. Just replace the cos power 4x with sin square x. So you have cos square x plus sin square x. Okay, so I know very well that cos square x plus sin square x is anyway 1. So that is our RHS. That's proved. So this is the LHS part. So this is our LHS, and then you got the RHS. So hence proved, that's QED, hence proved. Okay, this is a pretty easy problem but somewhat tricky. Okay, so this relationship will use it and then we'll exploit this relationship to handle this. Okay, unless you know this relationship, unless this relationship is given here, you can't solve this problem. Of course, this is connected to this relationship. Okay, now let's go to the next question. In this video I'm covering two questions together. So here let's go to the next question. So it's given that sin x plus cosecant x is equal to 2, and then you got to show that sin x plus cosecant x is 2. Then you got to show that sin power nx plus cosecant power nx. Okay, so that n value is any integer, any positive integer. Sin power nx plus cosecant power nx is equal to 2. This we got to show, and then for this what I will do is, let's write the equation first, what they have given us. So it is sin x plus cosecant x, this happens to be 2. They have given that. So what I will do is, let us assume for some time that sin x is equal to some y. So the cosecant x is the reciprocal of sin x. Obviously cosecant x becomes 1 by y, right? So let's plug these things here. So this becomes like y plus 1 by y. Okay, so this becomes 2. So let us take the LCM and let's multiply the things. So you get y square plus 1 whole divided by y is what you get, that is equal to 2. Okay, now let's do a little, and then this y just multiply onto the other side. So you get y square plus 1 this side, that is equal to 2y, and 2y, let's swing it this side. So you have y square minus 2y plus 1, that is equal to 0. Y square minus 2y plus 1 is nothing but y minus 1 whole square. Okay, so y minus 1 whole square, which is equal to 0. So y minus 1 whole square is equal to 0. What does that mean? So the value of y is obviously 1. So you are getting a coincident roots for this quadratic equation. So y value is 1. So where we started, the value of y we assumed as sin x as y we assumed. So the value of sin x is 1. So obviously the value of x is 90 degrees, or you can say it is pi by 2. Okay, 90 degrees or pi by 2. Of course, radian measure. So if sin x is 1, what will be the value of cosecant x? The cosecant x value is also 1, right? So what I have to do, they asked what's the value of sine power n or sine power nx plus cosecant power nx, right? This is what they asked us. So, but we know the values of sin x and cosecant x are 1 and 1 each. So, it is simply 1 power n plus 1 power n. So, it's simply that it is 1 plus 1 that equals to 2. Hence the problem. That's the solution. That's the required solution we have. So, that's it guys, and let's meet at the next problem. So let's see the next set of questions. We have a situation given that sin x plus sin square x happens to be 1, and then you got to show that cos power 12x plus 3 cos power 10x plus 3 cos power 8x plus cos power 6x happens to be 1. So the second part of the question is you got to show that cos power 8x plus 2 cos power 6x plus cos power 4x have to be 1. I will take the part B of the question initially to solve, so that is little bit easier to solve, so that you will understand. So here let's consider the situation that you have sin x plus sin square x happens to be 1, and you know that this is the earlier situation what you are saying. So you have sin x is equal to 1 minus sin square x. You can take the sin square x onto the other side. So 1 minus sin square x. 1 minus sin square x is nothing but cos square x. This is the earlier situation what we are seeing. So earlier they have given the situation sin x equal to cos square x. The same situation we are seeing once again. Okay. So now we see that I can very well write, if I square it on either side, I will get that sin square x. I have cos power 4x. Wherever I see cos power 4x, I can replace with sin square x, of course. Okay. So and again, so if what if I just cube this? Okay. So if I take sine cube x, so that is cos square x whole cube, right? So it becomes cos power 6x. Okay. I just here the power is multiplied by 3 over here. So here also the power is multiplied by 3. So this is as simple as that. Okay, let's consider the part B of the question first. So because it is easier. So it's cos power 8x over here plus 2 cos power 6x. Just I'm rewriting the things. So that's the LHS which I am rewriting. Okay. So you have cos power 4x. Okay. Now so let's understand this. This is a pretty simple task. Now what would be if I consider sine power 4x? Okay. So I have sin x is cos square x. So if I take sine power 4x, that is nothing but cos power 8x. Okay. So I can keep writing this relation just by squaring and cubing and taking to the power 4. So how does that goes? So cos power 8x is, I can replace with sine power 4x plus 2 into, let me write this as cos square x into cos power 4x. Let's write like this. So that is cos power 6x can be written as cos square x into cos power 4x. This is what the thing I did. And now you have cos power 4x is the other part you have. Right. Now the cos power 4x, let us replace with sin square x once again. So I have sin power 4x plus 2 cos square x sin square x, 2 cos square x sin square x plus cos power 4x is what you have. Okay. So let's write the next part. This is afterwards is, it's pretty easy. Now it goes as, I can write this as sin square x whole square, right? Plus I will rewrite this as 2 sin square x cos square x, 2 sin square x cos square x. Okay, and then I rewrite this as plus cos square x whole square. Okay, what is this stuff? This is like a square plus 2ab plus b square. Okay. So this is nothing but a plus b whole square. So this becomes sin square x plus cos square x whole square. So sin square x plus cos square x is 1, and so this is 1 square, hence that's 1. So which is the RHS? This second part of the problem is proved. Okay. Now we had to go to the part A. This is the second part of the problem. The first part of the problem we need to solve. So what's the first part of the problem? Let's rewrite that here. So we had to know, what are the things we had to know? We know this is the thing in hand. Okay, sin x is cos square x. So wherever I see the sin cube x, that becomes cos power 6x. Okay. So if I have to make it like sin power 6x, what will be sin power 6x? That means the on the other side the cosine also to be raised to the power cos square x to be raised to the power 6, right? So it becomes cos power 12x. So like this you can keep writing the relationships. So this is the important thing what you have to know to solve this problem. Okay, so let's see the terms what are there. It looks complicated, but it's an easy question. But we'll see. The cos power 12x plus 3 cos power 10x. Okay, so let's write that. Cos power 12x plus 3 cos power 10x. So let's write the next part. Some two more terms are there. So that is 3 cos power 8x plus cos power 6x. So 3 cos power 8x plus 3 cos power 8x plus cos power 6x. This is what the crux is. Now, so this is what we have to solve. So I just told this, this one. Wherever cos power 12x is there, let's replace with sin power 6x. Okay. You'll understand why I am doing like that. Okay. It's very easy. So the thing is that I want to bring it like sin square x plus cos square x whole cube. So this one I replace with sin power 6x. Okay. And this is 3 cos power 10x. Okay, let's keep it for time being. I'll tell you what we have to do here. So this is 3 cos power 8x, like this. Let us keep it, don't worry much about this. So let's keep the cos power 6x as it is. Okay, now the stuff what we had to do is this, somehow I had to bring it like sin square x plus cos square x whole cube. That is the crux. So let's write this as sin square x whole cube. Okay, first part, this is like a cube plus b cube. B cube thing is here. Okay, so that is cos square x whole cube. Okay, that is cos power 6x. And now the other stuff is like 3ab times a plus b, like that you have to somehow bring. So the thing is that what we will do is we will write 3 cos power, what I can do is cos square x. Okay, cos power 4x, let us write cos power 4x into cos power 6x, let us write like this, and then this, let us say, that is 3 times, I can write this as cos power 4x into cos power 4x. Let us write like this for some time. So let's see what happens. Okay, so I need to see 3ab into a plus b. So let's rewrite. So rewriting will do. So here let us replace the things. So I have sin square x here, sin square x whole cube plus cos square x whole cube. Okay, so wherever cos power 4x is there, I can replace with sin square x. So I'll replace 3 sin square x I have, and again let us have this cos power 6x. Okay, let us write this cos power 6x for time being. I will tell you slowly. We'll do this. So what else we have? I need something like, yeah, I need something like, okay, 3 cos power 6x. Let's write this like this: 3 cos power 6x and multiplied by cos square x. Let us do like this. Okay, cos square x. And now here we do some more things, some more transformation we need to do. So what is that? That is sine square x whole cube plus cos square x whole cube. Okay, plus 3. I have, you see this, this is 3 cos power 6x is there and 3 cos power 6x is there. Just take out this cos power 6x first. So 3 cos power 6x, if I take common, I get sine square x plus cos square x. Okay, okay, I got this. Almost it's over. Okay. Now I had to do a little bit transformation here, and then we are getting that form. So don't write this sine square x plus cos square x as 1. Okay, I'm telling that. Why I tell you, you'll understand. This is a little bit, in this sense, it is a little bit a complicated problem. This is like sine square x whole cube plus you have cos square x whole cube. Okay, so you have a cube plus b cube pattern is there, plus 3ab is what I need. So 3 into, let us write this as yeah, if I write directly you will get confused. Okay, I'll write 3 cos square x into cos power 4x. Let us write like this. Okay, so the cos power 6x I am breaking like this, and then let's write this as sine square x plus cos square x. Okay, so afterwards it is, so let's replace the cos power 4x wherever it is there, that we can replace with sine square x. So let's rewrite the stuff. So let's write this. So you have sine square x whole cube plus cos square x whole cube you have, plus 3 sine square x multiplied by cos square x you have, and you have sine square x plus cos square x. Okay, we have all the ingredients to make the curry. Fine. So you have the, see the thing, this is a cube plus b cube plus 3ab multiplied by a plus b. This is nothing but a plus b whole cube. Okay, so the a plus b whole cube is over. So it is like sine square x plus cos square x whole cube. So you have this. Okay, so this happens to be equal to 1 cube, which is 1. So with that, this problem is over. Hope you like it. Let's meet in the next problem.